Okay, we are going to start looking at something called transformations. So, transformation refers to any change in a figure. Specifically, it's an operation that maps an original figure called the pre-image onto a new figure called the image. Which is kind of strange because it's like we're starting with the pre before we get to the image, but the pre-image means this is our beginning part. After we do whatever change is asked, we get the image. Okay, so this transformation is an operation that takes a shape called the pre-image and changes it to something called the image. A transformation can change the size, position, or shape of a figure. Now, we won't get into anything when we look at shape of a figure. In our case, it doesn't mean we're turning triangles into rectangles. When we refer to the shape of a figure, it could turn a triangle that is in where the point is at the bottom, and it becomes a triangle where the point's on top. That's what it means by the shape. Okay, so we're not turning triangles into trapezoids or anything like that. Very basic changes. All right, so the first transformation that we are going to talk about will be a reflection. Reflection is something that you have probably heard of before. We all have a mirror. Mirrors have a reflection. So that's what we're looking at first. Okay, let's gather a little information. A reflection over a line is called the line of reflection. So you'll be asked, or you'll be given the line of reflection. Okay, you'll be told what this is. Okay, so again, you'll be given the reflection instructions, and we call those the line of reflection. Okay, the second point, or information, each point and its image are the same distance from the line of reflection. And you'll be able to see this in action in a few minutes. But remember, whenever we're dealing with a reflection, your image versus pre-image, the points are going to be equal distance from the line of reflection. Now, with these line of reflections, there are different options for where the reflection is. Or you could think of it like where the mirror would be. Okay, so the first possible line would be on the x-axis or y-axis. It could be a vertical or a horizontal line. Oops, that should say lines. In the form of y equals a number or x equals a number. So the x-axis or y-axis could be our line of reflection. A vertical or horizontal line could be the line of reflection. Or you could actually have a regular line, like the lines that we've been graphing, in the form of y equals mx or y equals mx plus b. So we have all different possibilities of how the line will reflect. So we're going to go through some examples. We're going to look at every single possible line of reflection. We'll do one of each type. And then you should be able to recreate them on your own. All right, so let's look at number one. Number one says we have a triangle ABC with vertices A, B, and C. So it gives you, the vertice is the point of the figure. Okay, so the ordered pair of the corners. Okay, so the ordered pair of the corners is what they give you. Now, one thing that's important is we're going to have to label these points. Okay, so let's start with A. So A is -4, 2. So I go backwards 4, up 2. It's very important that you plot the points correctly. If the points are plotted correctly or incorrectly, your answer is going to be completely wrong. So be careful to plot correctly. B is 4, 7. 1, 2, 3, 4, up 7. Label that B. And C is 5, 1. So again, just double check that you've plotted everything correctly. And we label A, B, and C. Okay, so then what we want to do is we are making a triangle, so we do want to connect our points. Make ourselves a triangle with our points. Definitely need to make that shape. Okay, so here's our triangle ABC, and it says we're going to reflect it on the x-axis. So that means that the x-axis is our mirror. So what I like to do is I'll take a different color. Oops. And I'll draw a line on my line of reflection. I'll actually make a line of reflection on my paper. Okay, or sometimes what I'll do is I'll do like a little squiggly line so that I know what the line of reflection is. Okay, but make yourself physically draw this line so that as you're working through the problem, you can remember where your mirror is or where your reflective line is. So now if we look back at our information about reflections, the second bullet point says each point and its image are the same distance from the line of reflection. Okay, so we're looking at this one right here. Each point and its image are the same distance from the line of reflection. So what that means is when I'm creating my image from the pre-image, I have A is here. A is 2 units from my line of reflection. So that means if A is 2 units above the line of reflection, my new A is going to be 2 units below. And we call this A prime. It has the little apostrophe. So my ordered pair for A prime is -4, -2. Make sure you label. It'll be important, especially as we get into some more difficult reflections. So B, I know, is 7 units above the x-axis. And the reason I know that is because I'm looking for the y-coordinate of B up here. My y-coordinate's 7. So that means this B is 7 units above. Okay, if that's tricky for you, just count your units. 1, 2, 3, 4, 5, 6, 7. Okay, now I wouldn't draw a line on your paper just because I don't want you to get confused. But B is 7 units above, so my B prime will be 7 units below. 3, 4, 5, 6, 7. And label it B prime. And the ordered pair for B prime will be 4, -7. C. Okay, so C is 1 unit above my line of reflection, so C prime will be 1 unit below. And then let's connect our points to make our new triangle. And let me make sure I put my C prime ordered pair. 5, -1. Okay. Now, one thing you might notice, if we look at our ordered pairs, do you see how, look at our x coordinates from A prime to A and B to B prime. You'll notice the x coordinates stay the same and something happens to the y coordinates. It's a good way to double check. If my line of reflection is on the x-axis, you'll notice that my y coordinates are the opposite. That's something you can remember if you want, not required. Not trying to have you remember 8 different rules. All you have to remember is that the image and the pre-image are the same distance from the line of reflection. And that's what gives us this mirror image. All right, next up, number 3. Trapezoid FGHI with vertices, and it lists them in the y-axis. So our reflection point is going to be the y-axis. So this is our line of reflection. Let's go ahead and plot our points. So F is -5, -2. G is -2, -2. H is 0, -6. And I is -8, -6. Oh, that's horrible. Let me get my line total. So connect our points, make our trapezoid. Definitely use a straight edge for this so that you don't have kinds of crazy squiggles like I had a second ago. All right. Okay, so now we look at, there we go. Okay, so now we want to find our reflection. Okay, so our shape reflected over the y-axis. So remember, we're looking for the equal distance from the line of reflection. So in this case, it's the y-axis. So for F, my distance is 1, 2, 3, 4, 5. So if it's 5 to the left, I'm going to go 5 to the right. 1, 2, 3, 4, 5. And here's my F prime, which is at 5, -2. So G is 2 units from the line of reflection. So G prime will be 2 units from the line of reflection. So that's going to be 2, -2. H, when you have a point that's on the line of reflection, it's 0 units away. It's on the line. So if it's 0 units away, on my H prime is going to be 0 units away. So my H and H prime are actually the same exact point, just because it's on the line of reflection. I was 8 units away, so I prime is going to be 8 units away. Let's connect up our points. I forgot to put my coordinates for I prime, so we'll do that next. I prime was +8, -6. Right, so if you'd like, you can move on and work, well, we can do the next example, or you can pause here and work on numbers 2 and 4. That's your practice for the night. If you'd like to work on them now, you can work on them now, or we'll move on to number 5 next. Okay, so our next example, we have a triangle with the vertices J, 1, -1. K is 2, 3. And L is 3, -2. Now for our line of reflection, it says our line of reflection is x equals 4. So this isn't just x-axis or y-axis. Now, if you remember with graphing lines, when you have an equation where there is no y or x, or there's only one or the other, we're looking at a horizontal or vertical line. In this case, if you were to draw a table, don't, but if you were, and you tried to get x and y coordinates, no matter what y you picked, you could pick anything. The x would always be what? 4. So no matter what y you pick, x would always be 4. No matter what y you picked, x would always be 4. If y was -4, x would be 4. If y was -8, x would be 4. And so what you end up with is a vertical line at x equals 4. And that's our point of reflection, or our line of reflection. So when I try to find my new image from for example, from J, I need to find the distance that J is from my line of reflection. And J is 3 units away from my line of reflection. So if J is 3 units to the left, J prime will be 3 units to the right. Okay, so I'll be at, let's see, 1, 2, 3, 4, 5, 6, 7. 7, -1. For K, K was 2 units away from the line of reflection, so K prime will be 2 units in the other direction. So if K is 2 units to the left, K prime will be 2 units to the right. So K will be 6, 3. L, if L is 1 unit to the left of my line of reflection, L prime will be 1 unit to the right. So L is going to be at 4, 5, -2. Then all we have to do is connect our points. And there's our reflection. And if you look, you can see that it's a mirror image.